Hello guys, welcome to another Software Dev 1 video. Today we'll be doing Lab 5 and I know it's important for your exam, so I just wanna do it with you guys and hopefully give you a better understanding of classes and how they work. So in the lab, you're required to complete the implementation code found in complexcalculator.cpp, templates for the class header file complexcalculator.h, client code main.cpp, and implementation code complexcalculator.cpp can be downloaded from Sakai. Okay, the complex calculator class is required to perform the following tasks. Okay, add, subtract, multiply, divide, find magnitude, phase, and print out your answers. Okay, then it says pay special attention to the comments in the header template. Okay, so right, let's quickly. Alright, so what I've done is make a project, um, and yeah, you know how you normally do. Okay, so there's my main. I'm quickly gonna grab. Yeah, oh, using the wrong buttons. Okay. Alright, so that's my main, right? Just gonna save that. I wanted to show you how to put in new files into your project without um, a hassle. So this is like a shortcut method. So you're gonna press Control, right, plus Shift plus N, right, and this will add a new file. All right, so I'm quickly gonna do that. Control Shift N. Okay, and then this will pop up. Do you want to add this new file in the active project? But it has to be saved first. So I'm like, yeah, I do. Okay, so can you see where it takes me? It takes me into the project file, okay? And I want to call this complex calculator dot 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 uh dot cpp, right? And then okay, yeah, so there's another one, right? So it's there as well. It's in the same place as main. And I'm just gonna implementation code, right? Control O, copy, paste, save. And then I'm gonna do it one more time do it one more time. And this will be complex calculator dot h for header, right? Dot h, save that. Ooh, what's going on? All right, and can you see because it has the file extension .h, it makes a header file for you, and then header folder, and then puts it in there for you. Okay, cool. Now moving on. Okay. What's the next step? Okay, yeah, I need to help you understand what classes are exactly. Let's go there. Okay, so um, let's imagine your mom said you need to make um, uh, 5 fruit baskets. Okay, so let's see. That's a fruit basket, right? And then uh, let's say these are like fruits, whatever. Okay, but because you're lazy, your mom told you to make five, you made one, and then you told your sibling, let's say your brother and sister, to make the other four. So what you did is you gave them this one, okay? Come on, man, come on. Right. So you gave your sibling one, and then you told them, all right, follow the same steps and make others. And uh, let's say in this one you put two oranges, right? This was the original one, and one banana. Okay. Now, please don't mind my spelling. So maybe the next one you tell your brother, no, put or sister to put two apples and two bananas, right? But still make sure it's a fruit bowl. And then yeah, so and each different one, maybe you want different fruits to be in them, right? Okay. So what it went what we do with classes is that we make a structure, right? For example, this fruit bowl. And what we're saying is that in our code, we wanna use the structure, but make copies of it, or have different copies have different properties. For example, the fruit bowls, right? So the original one might have this, okay, but the next one you want might have this inside, but it will still be fruit bowls, okay, and they'll all be copies of this original with maybe the difference being the fruits inside, okay. So that's what classes are. Instead of coding multiple um, multiple copies or instances of the same thing, you wanna use this and make copies, right? So make one as a class, and then every time you want to use it, just assign uh, different variables to it. Okay. Uh, let's see another way I can explain. When we have tests or labs to do, and they require us to use a function. Let's say uh, string greet, and then taking a string name, right? And then your main will be somewhere here. Uh, okay, so normally what happens is you make a function on top and then you use it in main, right? But you're actually making you've done a lot of things uh, during this process. So on top here, what you've done is that you have declared a function, right? And then what you've done here is define, oh man, my handwriting. You've defined the function, right? And then over here, you're probably like using it in main, okay? So yeah, okay. So when it comes to classes, okay, every time you wanna, let's say you have a class, okay, and then every time you wanna, Oh no, that's not the right thing. Yeah, so you have a class and you want to incorporate it into main, okay? The first thing you do is you will have a separate file where you declare what functions you have in your class. So that would go in your header file. So they're called templates, but they're just declarations. And these are found in your .h file, right? So your header file. And then you have your definitions, right? Which are also known as your implementations of your functions, right? And this is found in your .cpp file, okay? And then you have your client code, which is also where you use your class, where class is used. And this is your main.cpp. Okay, so that refers to this part, and this refers to this part here. Let's just make that and make this white. Cool. So that's how it would be. So that's all we're doing. So I hope that was a bit clear. You understand. You understood. Okay. So it's exactly what I've done here. Here's my main, right? There's main as it was given. There's the implementation code for the, excuse me, for the class, which we have to code, right? We need to add some things there. And then the header file. Oh, I didn't import the header file yet. Yes, save. Cool. And then this is our header file. Okay, so I'm quickly gonna start from the header file and then go to main. Okay, so look, look. The first thing we see is the struct. Let me use a mouse. It's much easier. Alright, the first thing we use is the struct, right? And what the struct, what is a struct? A struct is a struct is a data type that we make from existing data types. Okay, and what that means is that let's say you want to have a variable or like if, for example, like even this complex number, right? You want it to have a real part and imaginary part. So each of those need to be, in this case, floats, right? Let's make another example. Let's say struct. Uh, you want to make a student, right? And what would your student consist of? Your student can, let's make it simple. Your student will consist of a name, so name, right? Let's say I'll use my name. And let's say the student will consist of a student number, so that's an integer, right? What do we put? Let's put a student number that doesn't exist. Okay, so I think I want one digit over. Yeah. Alright, so that's the name and the student number. So every time I want to use, for example, the name of the student, I first have to declare. Alright, I'll show you how to use. I'll demonstrate how to use structs using the complex number, but I was just showing you what structs are. I hope you'll understand that. Alright, so next thing, here's the class, right? So you're telling your IDE, make a class and call it complex calculator, right? So there's normally these two uh, definitions, or what can I say? There's two parts of the class, right? So you have private, which would store your private variables or functions, and public, which stores your public variables or functions. And then what private, okay, let's start with public. What public, every time you make a function or declare a function under public, that means it is available for every, uh, what is it? What can I say? It can be used or accessed anywhere else in the code. So I'm quickly gonna go to main, okay, and show you. So can you see, for example, where was I? I was here, right? No, I was here. For example, okay, complex number add, okay, complex number add uh, is being used here. Okay, can you see there's this add function, right? And it's not declared anywhere else, just used here, and that works. So that's because it was made public, right? Yeah, okay, let's go on. Another thing that might have confused you is seeing that complex number is used here on this side, and that you might have said, okay, what's going on? So what this means is that, remember, a struct is a data type, right? So whenever you make a function and you use a complex number in the beginning, that means that in this function called add, you're going to be returning a complex number. That's all it means. If, for example, it was int and then add and then, okay, these are parameters, then you know the function would be returning what? An integer. Okay, okay. So these just mean that all these functions here, these four, are going to be returning complex numbers, which are structures or structs, and these structs have two variables in them, and both of them are floats, right? So for the real and imaginary part. Okay, so each of these first four functions take in two parameters, and these two parameters stand for the first and second numbers that we're going to use to perform the add, subtract, multiply, and divide. Okay, and then the next two functions perform magnitude and phase calculations. They take in one parameter, and the parameter we use is a complex number, right? Remember, that's a data type. Like even these first four functions, they take in data types called complex number. I mean, not called, but they are of type complex number. And then remember, void function returns nothing, so we just print. It says print complex number. I'm assuming you're gonna print this complex number x. Okay, let us go. Okay, so this is the header file, right? So far, what we've. Alright. Oh, no, 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 no. Alright. So far, what we looked at was this part of the code, right? So remember, so you have your class, and you have main, right? And then this is client code, right? Right, so far we went over .h, right, which just has our declarations. And then we have a .cpp inside the class, right? We'll have our definitions. And then here we just have main.cpp. Okay. What's the time? Ooh, it's getting late. Okay. So, yes. Another thing about this private, right? It's like, let's say, what can I say? What can I say? Let's say you're making some game, okay, which I knew you all had to do, and you didn't want one of the players to change their own score, right? If you look in main, right, when you use these add or subtract or multiply functions, it allows you to put in numbers, right? That's all. That's what you can do. So if you had some function here that says like int take score, right? And your variable, or like, okay, this is the variable take score, right? And you're like, okay, set it to 0, and then you have some function that increments this, right? This is accessible to main, meaning if someone was playing the game and they wanted to change their own score, they could have, because it's in public. But if you didn't want someone to manipulate that scoring, uh, that scoring variable, right? You'd put it in here. You'd put it like int take score or keep score, whatever, in there, and then that won't be accessible to anything outside the class. Okay, unless you give that thing permission, which main doesn't have permission. Okay. What else did I want to say? Okay, let's go on. Right, so header files, I hope you understand. Okay, let me explain the other things. So these are important. It just tells you that it's a header file and it's defined as this. Okay, so can you see the struct is outside the class? Okay, the struct is outside the class. Okay, and that's also fine. It's still going to be in the header file. Okay, and this variables, right? They can be manipulated in here if the code uh, required that, okay, or the lecturer wanted to do that, okay. And every time, yeah, okay, this hashtag ndif is also important. So every time when we want to use does declarations for this class, right, we need to put hashtag include the file name.h, right? So that's the same as the, excuse me, the header file. So now let's look at the implementation file for the class called complex calculator. The first thing you see is that we're using this hashtag include complex, excuse me, calculator.h. So what's happening is that your IDE is like, okay, in this file, this .cpp file, I can use things from the .h file. Okay, that's what this line says. It recognizes that there is a struct in there called complex number. It recognizes that there is a class declaration in there. It recognizes that these functions exist. It doesn't know what they do yet, but it knows that they exist. Okay, so in your implementation file, what you would have is your definitions of each and every function. Meaning in here you're gonna write now, okay, what does add actually do? Add does what? It takes the first number and it adds the second number, right? That's what it's gonna do. Okay, and then we're gonna have to write these out because can you see they're blank? All of them are just blank. We're gonna have to actually write out what each and every one of these functions do. Whenever you, okay, this header file has one class. Let's say you had 5 classes in here, right? The way you, yes, these 5 classes, and each one of these classes has add in them, okay, and returns a struct of complex number, okay. You need to tell it which class it comes from, okay. So what you normally do is give the return type, then you give the class name, and then you use this thing, what is it called, scope, is it a scope, let's google it quickly. um, uh, um, Scope resolution operator. Okay, so every time you use a scope resolution operator, you are saying, okay, kind of saying, look in this class for this return type, there should be a function called add that takes in this parameter and then perform this function. So, like we said, like maybe first plus second, okay, whatever, right? And can you see that it needs to return some complex number, right? So it needs to have a return. This function needs to have a return. This one needs to as well, this one needs to as well, this one needs to as well. And then this one will return a float, right? This is where we do our magnitude calculation, float, and then void returns nothing. So here you just have like your C out, blah, blah, blah. Okay, now, okay, so far we're done with the class, right? Now, what happens in main is you are using the class. What's the class name? Complex calculator, right? Can you see you don't include the .cpp file? You just include what? The .header file. It's part of your data protection. You don't, and also this is what your client would see. This is what, if you're gonna give your code to someone, this is what they would see. You don't give them this file would be invisible to them. It will be here, but it will be protected. You won't be able to view it. And this .header file could also be like invisible as well. Yeah, it should also be invisible. It shouldn't be able to edit this, and shouldn't be to edit able to edit this. They can edit main, right? Because that's where maybe they want to put their numbers or change some things. Okay. So every time you want to use a class in main, you call the name of the class and you assign to it some object, right? Remember when we did uh, using input files, what we normally do would be ifstream, right? And then you'd normally go like this, infile, right? So what you're actually doing here is from this, from the fstream, I don't know if it's a library, yeah, library, you are saying you want to use this operation ifstream and you want to do it through this object that you named yourself called infile, okay? And then what we normally do is saying infile dot open, right? So what we were doing is saying inside this ifstream, right? There's a function. Let's say the ifstream is a class. There is a function called open. Can you see that? And it takes in a parameter, right? And that parameter is what? The file name. And we normally say input.text. So remember to use a function in this class, you would use the object that you declared, right? In this case, it was infile, and you'd use a dot to signify that you want to use a function in this class, and then the available function should pop up. Let me just show you like that. So all these are like functions that are inside there, and you just select the one that you want to use and dot open, right? And then that's when you put in the parameter. Okay, so similarly, complex calculator is the class, calc is the object, and every time we want to use a function from this class, we say calc dot, and then all the functions in this class appear, all the available functions. Okay, let's try that. So calc dot, can you see that the add, divide, magnitude, multiply, phase, print, and subtract all appear? So I can use one of these, and then it even tells me what needs to go inside of it. So it tells me that this add function needs to have two parameters. One would be, both of them are complex numbers. There it is there. Okay, cool. So, sorry. For this one specifically, uh, let's look at this quickly. Where is the Alright, so our add needs to print that, subtract, multiply, divide, magnitude, and phase. Okay, okay. Let's save all these files first. Okay, okay, right. Okay, so, right. Because I've included this .h file, right? It even knows what the data type complex number is, and it has no problem taking in these variables, right? The problem comes where, uh, what is it? These functions are used, add, subtract. Let's run the code and then take it from there. Alright, so I'm running the code. Alright, so these get printed, but like there's no numbers there, right? We're supposed to get numbers. So these functions are problems. So what's actually the problem, right? So in your header file, there's nothing you need to change. All the functions have been declared for you. So here's where the problem is. So let's start. Oh, guys, it's so cold. Okay, since I'm going to be returning a complex number, right, I'm going to make another variable of type complex number, okay, and I'll call it addition, okay. And remember, every complex number made has two parts to it, right? It has what? A real part, which is a float, and an imaginary part, which is a float. So I'm going to use that, right? So addition dot, can you see? And I press the dots, the two possible uh, parts of the two parts of it actually pop up, and I'm gonna choose the real for now. And according to the comments, add first to second. So add first. Remember, this is a complex number as well. So how we add complex numbers is to add their real parts. So first dot real and second dot real, and then addition dot imaginary is gonna be the first part dot imaginary plus the second dot imaginary. Okay, done. Let's do subtract. How do we do subtract? So subtract, subtract dot real is gonna equals to, so subtract second number from the first. So first dot real and then subtract second dot real and then subtract. Oh, whoa, I'm making a big mistake. I'm going to make a variable called complex number, and let's call it subtraction, and then this will be subtraction dot real, subtraction dot imaginary, subtraction. It's going to equals to first dot imaginary minus second dot imaginary. Yes, subtraction, subtract. Okay, let's go on to multiply. Okay, so I'm going to assume you'll know how to I'm going to assume you'll know how to multiply complex numbers, right? So I'm not going to waste too much time on it. This video is more to show you how multiplication is to show you how classes work with headers and stuff. Okay, so all right, when we add when we multiply complex numbers, right, you need to mind that I, right, because you're doing the FOIL method first, outer inner last, then you're multiplying, what is it, you're multiplying two brackets together that have two terms each inside, so you need to do FOIL. And depending on the signs of the first dot imaginary times the second dot imaginary, right? So if you find that after you've multiplied the two numbers, let's say they're both positive, right? Because of that I that is there, remember you have I times I, so it's I squared. So it becomes a negative sign, right? Because I times I is equals to -1. Okay, so you'd have multiplication dot real is equals to the first number, the real part of the first number times the real part of the second number, right? And then you are going to subtract the imaginary part of the first number times the imaginary part of the second number. And then for your imaginary, you're going to do the same thing, but you're not going to minus this time. Imaginary, it's going to be like this. Okay, let's see if that's correct. Yes, 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 yes. Okay. Else, else. You take your plus plus. Okay. Imaginary. Okay. So if you add, so this is when you're multiplying, for example, 9i times 9i, right? Remember, your variable you're taking in is a float, so you're just taking the 9. The I, we're not even using i's, right? Your code blocks doesn't know how to calculate complex numbers on its own, or this class that we made does not know. So the way we are doing it is just multiplying the numbers together. So you'd get 81 coming out if we had to multiply this. But that's not correct because of I times I is -1. So what I'm doing is that if I find that the number is positive, which in this case it is, I take that positive number, which would come out, where is it? Imaginary times imaginary, yeah. And then I'm saying, take this part and then do what? Put a minus sign there. That's basically it. Then you might be asking, okay, so how did Kevin get this part? So do FOIL and you understand. The way we do this part is that, remember, the first number you have, let's make an example. So it is clear, 3 plus 2i, 2 plus 3i. Okay, so if you multiply this 3 by this 2, that's a real number, so we're not going to look at that. Remember, we're doing the imaginary part, right? So you take this 3, which is the first real number, you multiply it by your second imaginary number, right? That's gonna be 9i, and then we are going to subtract. Yes, okay. I made a mistake there. It's supposed to be add. Yes, okay. Then you're going to add your first imaginary number times your second real number, that's 4i. Okay, so those two numbers are imaginary, right? So add. So else Remember now, else meaning that one of the numbers is I need to comment this, otherwise we're gonna get some funny business coming out. Yes. Else, if you have a minus there, right? So that's like, okay, you get the result, you get something that's less than 0. Okay, 9 times 9 is what? I mean, 9 times minus 9 is what? Is minus 81. But remember, the I squared makes another minus, so that makes a plus. So that's why I am going to take the absolute value of this. Okay, I was just being extra. And then because I'm using absolute, I'm going to use CMath, okay, in here. If you're using a function from CMath or something in your .cpp, include it in your .cpp. Don't go include it in your header and stuff. Using it here, you include it here. Okay, so far so good. This is what we do. Something I was not doing from the add, we're going to return addition. And then the second one, return subtraction. And then we're going to return multiplication. Why was this one not picking up that it's a complex number? I will debug later. Okay. Alright, so when we divide complex numbers, I hope you'll still remember, we need to multiply by 1, right? And the way we explicitly represent that 1 is as complex conjugates of our denominator. So let me quickly code what I just said. So complex number divided, make that, and I'm gonna also make conjugate. Okay, so our real part of the conjugate, because it also has a real and imaginary part, would be what? Would be our second number, right? Remember, we are dividing the first number by the second, so that's like, let's draw that. That's like, what is it? First over second. Right? For example, what I want to do is, if we have that 3 plus 2i over, what can it be? 3 minus 2i, right? On the top, you're going to multiply 3 plus 2i. That's the conjugate for the denominator. 3 plus 2i. Come on, clear up. Yes, so that's what we're planning to do. Okay. So I'm taking the real part, right, of the second term, okay, which is my denominator, the 3, that's what I put in. And then for the imaginary part, I'm going to take the imaginary part of the second term, but I want to multiply it by minus 1 to make it negative, right? Yep, that's all. And then complex. number. So I'm gonna make a numerator because it's a calculation I'm performing on top, right? And I'm going to use the multiply function. Multiply, because we made it here, so we don't need to repeat what we've done. And how do I see? Because I'm using it like in the same implementation file where .h is included, right? I don't need to declare the class and say maybe calc.multiply. No, I just use multiply straight because it's in the same class, okay? So multiply, and then on the top, what am I multiplying? So I'm multiplying the first, right? Remember, what does this take in? It takes in two complex numbers, so it's going to take in first and multiply it by what? The conjugate. So conjugate, like that. And then we're going to store the denominator as well. Denominator is going to equals to multiply second and conjugate. Okay, after we're done with that, let's do our let's actually divide the two answers we got, right? So we're gonna say divided is gonna equals to our numerator numerator dot real, don't forget, because remember there's two parts, our real. So this has to also be dot real. Yeah, so it's gonna be divided by the real part, and our imaginary part is gonna be the imaginary part of the numerator divided by, okay, remember when we multiply a number by its complex conjugate, we get what? The first number squared plus the second number squared. And when I say numbers, I don't mean this I parts. What are they called? Yeah, whatever. I forgot what it's called now. It's just the.
Don't forget to bring laptop, Kevin.
Yes, Mama. The number, whatever it's called. There's no. What I want to say is that when you multiply a number by its complex conjugate, there is no imaginary part that comes out, right? It's just gonna be a real number in the numerator. So when you divide it also by the real part, please. Don't divide by 0 and get the magical world appearing. Okay, then we're gonna return divided. Okay, let's go. For magnitude, do you remember how to do your magnitude calculation? So can you see that this function is returning a float? I'm not gonna make a variable of type complex number. I'm gonna make a variable of type float and call it magnitude. And magnitude is gonna equals to the square root of what? Something plus something, right? Square root of something plus something. Something plus something. Alright, cool. So on this side, we're gonna have x dot real squared. I'm using power, right? And on this side, we're gonna have gonna have, what are we gonna have? X dot imaginary squared. That work. Why does this one have an extra bracket? Because you want to do the power and then add. So you want to do the power. And then add it. Cool. And then is that it? Yes. So then we're gonna return magnitude like that. Okay, phase. Phase is a simple one. Again, returning a float. Okay, I'm gonna call it phase or phaser, and you are going to equals to arctan of y over x, right? So x dot imaginary over x dot real, and then return it to me. Return phasor. Done. Okay, when it comes to printing, this is the print function, yes. Okay, I did not include using namespace std, using namespace standard, right? Let's just include it. Okay, because I'm gonna use cout here, and oh yeah, I also need to use yes. This is what input output stream, because I'm using output. Okay, and I want to print. Let's look at the brief nicely. Let's remove this. Alright, so in the form real minus imaginary times I. Okay, so we have x dot real and there's no space, right? So x dot imaginary, and then you have times I, and then in the line. Okay, I'm going to okay, that's it. And then just want to look at main quick. Okay, main. Okay, let's build and run. Alright, we get this. Does this match what we're supposed to be doing? Let's minimize. Let's go here. Let's put it there. Okay, so that's correct. That's correct. That's correct. That's very wrong. That's correct. And that's correct. Okay. Let's go back here. So in my implementation, what is going on with divide? It's not divided. Imaginary parts. Numerator dot imaginary over the real, correct? There's a problem. Okay, so denominator, save, go run. Let's check it again. Yeah, we're in business, no? Okay, so that's done. Right, that is done. Let us move on to task 2. So write your own client side code main.cpp that completes the following and displays the results to terminal. Okay, so we gotta add these two numbers, subtract these two numbers, divide these two numbers, multiply these, and find the phase and magnitude of this one, and possibly get these outputs. Okay, we are gonna change. Remember now we're done with the implementation side, right? So let's go to main and try and change main accordingly. Can I try to? Okay, guys, just bear with me. I want to try to split this view so that it's easier. And then let's take this back up. Yeah, okay, good. Alright. What's going on now? Yes, yes. Oh yeah, I need to zoom so I can see better. Let me try and, my battery's gonna die. So I'll need the charger. I'm almost done.
Must bring it. Check if this window is closed. Do you know this?
Oh, it's cold, ne?
Window.
I think these things are even open. Oh, it is. It's not.
It's not closed.
It's closed.
Pull down the blinds, no?
But there is a wind coming in. Look, these windows don't close properly, even in my room.
And what ngitshele ngathi ashintshe le nto. Akafuni. Afake imali and what do you call them? The windows like innovation.
Oh, those big ones. Another 20 minutes. I'll be done. Alright, so alright. Charging is in. Let's go. Why does this keep happening? Okay, so let's see, 8. Okay. Yeah, I'm gonna make more variables. E F G H I G. Okay, and then the first real is what, 1.2, and then minus 10, and then 3.8, and then 909, and then let's give them space so you can see what we're doing. Minus 27, minus 0.5, 2.8, nine 9.09, minus 2, minus 2.7, right? E dimensional. A, B, C, D, E is minus 1. Minus 2.8. A, B, C, D, 9.09, and then where are we? G dot real. What are we doing? Minus 27. Okay, I hope you understand what I'm doing, right? So remember, there's the complex number, which is a data type. Remember, each variable here has two floats inside. Yeah? One float is what? For the real. One other float is what? For the imaginary, right? So because we have that built in, I am just using the numbers on the right and declaring variables for each and every one of them. Okay, and I'm going to use all these numbers, right, to add and whatever. So I'm adding, I put this in A and this is in B, right? So adding A and B, that's fine. And then I'm subtracting C and D, right? So I need to change this to C and D. Oh, okay. Let me explain what's happening here. So C is what? A complex number. It's declared there. Yeah, let me change it to J. I use J. I declared J, and I'm just going to use it to store my results for each and every one of them. Okay. And there was a simpler way to do this, but okay. Let's do it like this. Okay. So J will store, and so remember we have the class and the object. And down here, what we're doing, we're saying that calc the object dot add. Remember the function that takes in two complex numbers, right? Remember in our .cpp we actually wrote what it's supposed to do. So A will come in here and B will come in there, and then it just adds the real and imaginary parts, and then it returns the complex number called addition, right? That number gets saved in J, because J is also a complex number. So remember when we print calc.print complex number, it does what? What does print do? J comes in here, it prints out the real part of J, prints out the imaginary part of J, puts an I next to the imaginary part, and then ends the line. And then we're doing that for subtract, same thing, taking two numbers using the object calc dot, then call the function. Then you're printing out J. And then for multiply, be careful, remember there's divide in here, there's multiply. So this is A, B, C, D, E, F. So we're dividing E and F, okay? So I'm gonna go to divide, putting E and F, and then I print J. And then for multiply, I'm multiplying what? A, B, C, D, E, F, G, and H. So in multiply, I'm gonna put in G and H, and I'm gonna show what's stored in J. And then for our magnitude calculation, remember we're using undo. We're using I, and for our phase we're using I. Okay, and that's it. So let's compile and run. Okay. Is that clear? Not clear enough, right? Okay. Let's try and close this. Okay. So we need to compare these. Okay. Oh, minus as well. Okay, so we are getting the right answers, right? So if you look at subtract matches, divide matches, multiply matches, phase matches, magnitude matches, right? Things are just not in order, and there's no plus here. So I'm quickly gonna fix the plus thing, right? So if x dot imaginary is less than 0, so that's x dot real minus absolute of x dot imaginary, and then see out the I. Come on, what's going on? and then else. So I'm just writing them in one line, okay? So I'm not gonna. So if I find that the imaginary part is less than 0, I'm gonna manually insert a minus sign and then just use the absolute value of that imaginary part because I know for sure it's negative, so I can put that minus sign. And then if it's positive, I'm gonna put in a plus sign here. Plus, and that's it. What else did I want to fix? Yeah, I wanted to fix the amount of um, values that showed for divide because I see that they're actually showing three decimal places, right? So remember how we used to use the thingy? Oh, okay. So without using fixed, right? What you can actually do for divide, where is divide? Let me show you what to do. So you're gonna return divided, but you're gonna return the double of it. So it's gonna shrink it to double. Or I think they use the word truncated. And then let's see if that would work. Please work. Oh, come on, man. You serious? You're gonna let me do that? Okay. Where am I actually printing out? I'll print off, I'm not sure. That sucks. Divided. Let's try and shrink it here. So if I put double like on the outside, right, it actually shrinks it to a double. Let's try. Okay, that worked. But it didn't shrink the number for me. Uh, you look at that 636, right, there's it there, but then it also puts useless thing. Undo. Let's try and put it here. This way it worked. Nope. Okay, guys, I'm not gonna be shrinking this thing, but the correct outputs get printed. Okay, so yeah, so they match. Okay, they match more or less. Okay. What else do I need to show you? And it's basically it. Uh, let's try and maximize this window. There you go. Okay, guys, thank you for watching. All the best for your exam. Sorry for sending this late. I left it for the last day, and I did not have electricity, so that's why. Any questions you may ask me before the exam. All the best, guys. Goodbye.